Hi, today I'm going to talk about how to graph the sine function. And the way we do that is we first make a table of values of sine x for x going from 0 to 2 pi. That's one period of the sine function. And as we saw in a previous section, we can get the values of sine x going from 0 to pi over 2. Maybe I'll just show you quickly how to do that. So sine of 0 is obviously 0. Um, Sine of pi over 2 is 1. Remember, sine is like, you have, if you have the unit circle, these are circular functions. So if you have the value, the angle theta, then x is, this is the point xy, and x is just cosine theta, and y is sine theta. So um, when theta is 0, you can see that x is 1. That means cosine of theta, cosine of 0 is 1, and y is 0. That means sine of 0 is 0, like I showed. And when theta is pi over 2, the right angle, then we have sine of y is just sine x, which is 1. So that's how we get those values. To get the other values in this left column, what we do is we look at some simple right triangles. So for instance, let's look at a right triangle with an angle of pi over 6. That's 30 degrees. So this is really a 30, 60, 90 right triangle. This is pi over 3, which is 60 degrees. And you'll notice that this is half of an equilateral. So if this side has length 1, hypotenuse has length 1, then this whole side here is also 1. So this is 1 half. So the sine of 30 degrees is just opposite of hypotenuse, which is 1 half. So sine of pi over 6 is 1 half. To get sine of pi over 4, we look at a 45, 45, 90 right triangle, left-hand isosceles right triangle. So 45 degrees, remember, is the angle of the gradient of pi over 4. So, and if this length is 1, then by the Pythagorean theorem, we can see that the legs each have length 1 over square root of 2. Because 1 over square root of 2 squared plus 1 over square root of 2 plus squared equals 1. So this is going to be 1 over square root of 2. Or if you like, square root of 2 over 2. Same thing. Okay. So what about pi over 3? Well, pi over 3 we can get again from this 30, 60, 90 right triangle, except we draw it this way. So this is the angle of pi over 3, which is 60 degrees. And again, the hypotenuse has length 1. And again, this is half of an equilateral triangle, so this has 1 half, and this one by the Pythagorean theorem is square root of 3 over 2. So the sine of pi over 3 is square root of 3 over 2. So we've completed the left column. Well, that's nice, but now we want to complete the other 3 columns. How do we do that? Well, we make use of these 2 identities here. Sine of pi minus x equals sine of x, and sine of pi plus x equals minus sine of x. So we just look at 2 pi over 3, that's just pi minus pi over 3, so that's going to be the same thing. Sine of 2 pi over 3 is going to be square root of 3 over 2. Sine of 3 pi over 4 is the same as the sine of pi over 4, that's going to be square root of 2 over 2. Sine of 5 pi over 6 is the same as sine of pi over 6, that's 1 half. And sine of pi is the same as sine of 0, that's 0. And we can complete this table by using the other identity. Sine of pi plus x equals minus sine of x. So 7 pi over 6 is just pi plus pi over 6. That's going to give you minus a half. And then I'm just going to negate each of these entries. So we have minus square root of 2 over 2 for 5 pi over 4. For 4 pi over 3, we have minus square root of 3 over 2. For 3 pi over 2, we have minus 1. And then for 5 pi over 3, we look at this column, we'll just negate all the answers in that column. So those are the values of sine x for x going from 0 to 2 pi. Let me graph that. So I'm gonna actually go from minus 2 pi to 2 pi. And the sine's a periodic function, so it's just going to repeat itself. Going from minus 2 pi to 0 is going to be a repeated version from 0 to 2 pi. Let's just graph the values that I've drawn. So sine of 0 is x, this is sine of x. Sine of 0 is 0, like I've indicated. Sine of pi over 6, that's about here. So this goes up to 1, goes down to minus 1. The sine of pi over 6 is going to be 1/2. Sine of pi over 4, which is about here, is going to be square root of 2 over 2, which is about here. So far it looks like that, roughly. Sine of pi over 3, which is about here, is going to be square root of 3 over 2, which is about here. And then sine of pi over 2, which is about here, is going to be 1. So we're going to get something that looks like that, and then we, like I said, sine of pi minus x is sine of x, so we're just going to reflect the sine wave about this axis, x equals pi over 2, and we're going to get the same points going down. So we're going to get something that looks like that. And then when we go from pi to 2 pi, we just take this graph and negate all these points. So for instance, when we go to 7 pi over 6, we're going to be down at minus a half. And when we go to 5 pi over 4, we're going to be at minus square root of 2 over 2, roughly here. When we go to 4 pi over 3, we're going to be minus square root of 3 over 2. When we get to 3 pi over 2, we're going to be at minus 1. It's going to look like that, and then it gets reflected again about the line 3 pi over 2. So all these points are just a reflection of the points on the other side. So it's going to look like that. That's one period of the sine function. And then to get it from minus 2 pi to 0, you just repeat what it's doing over here, and I'm not going to draw the points, I'm just going to draw the shape roughly. So it goes down to minus 1, and then there's minus pi over 2, and then it goes back to 0 and minus pi, and then it's going to go up to 1 at minus 3 pi over 2, and then it's going to go back to 0, minus 2 pi. So it looks something like that. Anyway, that's how to graph the sine function, and that's all I have.